Uh, Good afternoon. Our project title is IoT-based human activity recognition using ARBITRARY with convolution network. Myself, Jayashree.
And myself Bhumika and the other teammate Sudicha.
So we are from final year IT and have done this project. Our project guide is Mrs. M. Ressa Vinoli Kutsi of IT department. The main aim of the project is to make a arbitrary with network where you have modified the number of channels instead of increasing the number of hidden layers, and also we have for real-time implementation we have demonstrated the model in a Raspberry Pi Node MC platform. Also, a website is created that detects the human activity, heart rate, and temperature of a person. Um, the objective of this is to recognize the human activity using the adaptive deep network, where we have altered the number of channels instead of number of increasing the number of hidden layers, and also to check how the network affects the heart accuracy, and to adapt the model in the Raspberry Pi Node MC platforms.
We have 5 dataset. For each dataset, we collect the data, we pre-process the data. While pre-processing, we found missing values and we corrected those values by changing the window size. Then followed by three-layer network. Then it's passed to fully connected layer and embedding the model in Raspberry Pi platform as well as in Node MCU platform and detecting the activities such as standing, walking, jogging, etc. This is the block diagram of our model. We use sensors such as accelerometer, gyroscope, magnetometer, etc. Then we pre-process the data. Then it is passed through the three-layer network. Then we detect the human activities such as sitting, standing, walking, upstairs, lying.
Data pre-processing. Sometimes the data may contain missing values and null values. So first it is pre-processed and compressed in window size for easier processing of our model. That whole data is divided into 70% of training data, 10% of validation data, and 20% of test data. Three-layer neural network. Here, three-layer network is used where the normal convolution layer is replaced by a lower triangle convolution network by masking the upper triangular matrix, and also the match normalization layer is used and the max pooling layer is used. After three layers, finally a fully connected layer will recognize the human activity, and and accuracy is also high. Noted it is higher. It is the algorithm of a model. It is built from a custom. It is built from a normal convolution network with custom layers, and the accuracy of the model and the time complexity of the model is also reduced. It is the example of our model. Where here 8 channels are given. For example, if the width, we have used a width multiplier. For example, if the width multiplier is 0.5, then half of the total number of channels is used. Then half of the 8 channels is used. That is 4 channel will be used for a processing each layer. This is the main concept of our model. It is also implemented in the algorithm. Um,
This is a block diagram using a hardware setup. This is the Raspberry Pi, which is connected with accelerometer, and Node MCU, which is embedded with accelerometer. Then using Wi-Fi signals, we collect the sensor data. Then we process the model in the GUI platform. We display it in a website.
Here in Raspberry Pi, the sensor is embedded with the Raspberry Pi, and the human activity is situated in the graphical user interface GUI, and also the Node MCU, the human activity, the heart rate and body temperature is measured by using a heart pulse sensor and MP60 based accelerometer sensor respectively, and
Applications are used by researchers and developers. Then in fitness enthusiasts to monitor the physical activity and track their process. Then by medical professional can use the system to monitor patients' activities and in rehabilitation programs.
this is the output of a model. While training, the accuracy of the model is plotted like this, and the training output is also given here. And while testing the model, the confusion matrix is generated, where in this example, for the width 0.5 and 0.25, the confusion matrix of the UCI hard data set is given, and the GUI output here, the basic activities like walking upstairs, walking downstairs, sitting activities are displayed in the GUI using the data set, and here experimental comparison. While training and testing the model with the various data sets, the accuracy of our proposed model is higher, and when comparing the model with the normal CNN, the accuracy of our proposed model is higher in both training and testing of data. And this is the hardware setup of our model. In Raspberry Pi, the accelerometer is connected with the Raspberry Pi, and in Node MCU, pulse sensor, accelerometer, and is connected to the Arduino, and the node is used for the Wi-Fi connection. And in Raspberry Pi, the real-time sensor values are detected and stored in a CSV file. The output is given here, and real-time human activities are displayed in a GUI in Raspberry Pi, and the web page creation, where it say tells the heart rate, body temperature, and human activity. Three basic activities, namely sitting, walking, and running, are given.
Uh, our conclusion, the research study we have proposed arbitrary with model which can dynamically adjust to the number of channels based on the width multiplier. Then a GUI was developed for in case of Raspberry Pi platform. Then a blog was developed which takes the real-time sensor values from accelerometer and displays the human activity, heart rate, and body temperature of a person.
Future work is that the complex activity is also detected. Now, as of now, we have detected the complex activity, and but what that activity is not detected. In the future, we'll do that, and also it can be used as a fitness pattern where it can tell the calories burned and the human activity, and provide feedback about the model. The location is also sent to the concerned persons. The output of the model is also given, where the activity is detected in the Raspberry Pi. It is the this is the output. In Node MCU, the website is created where the heart rate, body temperature, and activity of the person is detected. It is the output. Thank you.